we'll attempt the question together. Okay, we'll attempt the question together. Yeah. So for this question, right, it's 2023. Okay, and then for the digestive system, yes, anything?
Nothing.
Okay. I thought you are speaking. So yeah, let me put the sound become louder a bit. Wait for a while. Okay. You need to know about the structures in the digestive system. Yeah, starting from here, okay. Yeah, you can see, right? Yeah, you need to know every of the structure. Okay, so what is A? Okay, actually A, right? This A, right? Even though the question didn't ask you, but I tell you, A is a salivary gland.
Oh, okay.
Yeah, A is a salivary gland, which is the salivary glands, they will secrete the saliva, which is saliva in your mouth. And then how about B? Okay, what's B?
Esophagus.
Yeah, esophagus, correct, esophagus. And how about C?
The stomach.
Yeah, stomach, okay. And then K?
The liver.
Liver, how about J?
Is it the place? The gallbladder.
Yeah, it's a gallbladder. Okay, and then Monty, maybe you can tell me what is function of the liver? A liver, okay, is the one who produce the bile or it help to store the bile. Which one? Liver, it produce bile or it store bile?
The liver produces the bile, and then the gallbladder stores the.
Yeah, well done. Okay, you get the correct answer. Yeah, because this a lot of students, they just confuse it. They confuse it. Yeah. So well done, you get the correct answer. Then how about D? Okay, what's D?
It's the pancreas.
Yeah, it's pancreas. And then tell me what is the function of pancreas? Pancreas will secrete what kind of substance?
Enzyme.
Enzyme, correct. Okay, pancreas will secrete the enzyme. Then how about the E? E is the
Large intestine.
Yeah. And then how about H?
Small intestine.
Okay, and then how about G?
The anus.
Rectum.
Oh, rectum.
Yeah. Okay, rectum is part of the rectum is a part of large intestines. Okay, Monty, just for your information, this one you don't need to memorize, but I just let you know. Okay, you know that your small intestines, they have about 3 parts, right? There's 3 parts in the small intestine, which is the duodenum, and then another 2 parts is.
I forgot the names.
Okay. Yeah. The name is okay. I just put SI. SI means small intestines. So small intestines, you have about 3 parts, which is the duodenum. Okay, this is duodenum. Duodenum is the front part. Okay, the front part. And then you have the jejunum. Jejunum. Yeah, jejunum. And then the ileum. So just like DJI. Okay, DJI. And then for the large intestines, right? Yeah, large intestines, it is made from the rectums. Yeah, rectums. Rectums and the anus, okay, and the anus. Anus is F, okay. F is the anus. Yeah, anus is a part which is the feces will just come out.
Okay.
Okay, so they produce a bile. So which one? Yeah. Just as you say, it's a liver. Okay, so that's why this one is K, right? Yeah, this is a K. Then who produces the gastric juice?
The stomach.
Yeah, it's a stomach. They will produce a gastric juice, okay? And then inside the gastric juice, what is the pH for the gastric juice? The pH.
It's acidic.
How is the value of pH? Around pH 1, 2, 3, 4, 5. Which one?
3.
2. 2. Around 2. Okay, around 2. Yeah, around that 2. Because the gastric juice consists of the hydrochloric acids. Okay, it consists of hydrochloric acid. And then for this one, okay, who produced urea? Monty, who produced urea?
Large intestine.
Okay, the answer is urea. I'm not sure. Did I mention this to you before? Deaminations.
No.
Oh, okay. I'm so sorry. Okay, then that's my fault. Okay, who produces the urea? Liver. Liver is the organs who produce the urea. Which is this one, K. So this one answer is K. Liver is the one who produces the urea. Okay, later I'll show you how is the production of urea. And then for this one, okay, where maltose is digested?
The stomach.
Maltose, okay, stomach.
It's the salivary glands, like the mouth.
Salivary gland will digest the starch, right?
Oh,
Yeah, okay, I think you can have a look at here. Yeah, so just to talk about maltose, okay? But before maltose will be the starch, correct?
yeah.
Yeah, because the starch is a polysaccharide. So you have the starch combined with the water and then break down by the amylase and then become the maltose. So starch is a polysaccharide. So this is a polysaccharide, and then this maltose is a disaccharide,
Okay.
okay, which is a very large complex compound, which is a starch, and then a very much simpler molecule, which is a maltose. So this digestive, it's not digestive, sorry, digestions of the starch happen in two places. One will be in the mouth, okay? You know, in your mouth, you have a salivary amylase also. Yeah, in your mouth. Right here, okay? This is in the first place, they will digest the starch, okay? Not digest maltose, they'll just digest the starch, which is they will just convert starch, become the maltose. And then the second part will be the small intestines. Yeah, small intestine, they will just perform the digestions. Okay, yeah, which is here. Okay, where is it? Small intestines. Yeah, here. Okay, so the small intestines, they will perform the digestions, right? Yeah. So because small intestines, okay, Monty, let me ask you, this amylase, trypsin, and lipase is produced from which organs?
The pancreas.
Yes, well done. Okay, it's a pancreas. Yeah, so that's why pancreas, they just secrete out the enzyme, include the amylase, include trypsins, include lipase. But will pancreas carry out the digestions? No, right? They just secrete out the enzyme. So later the enzyme will be secret to where? They will be secret and released to the small intestines. So small intestine is the organs. Yeah, just remember that small intestine is the organs. They carry out the digestion process. Okay. Actually, Monty, small intestine, they have about two functions. First will be they will perform the digestions. So after they digest the food molecule, right, which is they will just break down the large food particle, become smaller food particle. So this is called digestion. So that's why they will just convert them, become a simpler compound. So from the starch, now become maltose. See, from the starch become maltose.
Okay.
Yeah, and then from the proteins, okay, the proteins will become the peptide, okay, and then for the lipid, they'll become the fatty acid glycerol. Now, maltose is being produced at the small intestines, and then it's being produced at where? It's being produced at the duodenum part of the small intestines. Okay, maltose, okay, is being produced at the duodenum part, okay, which is the front part of small intestines. So later, okay, maltose, right, is a disaccharide. So I think you know before, right? Disaccharide, can they directly be absorbed by the intestine villi? Can they?
Yeah.
No. Yeah, no, right? Because maltose is disaccharide, okay, it's still we call it the structure is still complex, unable to absorb by the villi, even though it become disaccharide already. So that's why maltose will be further broken down. Okay, they need to further digest, become what? Become glucose. Yeah, they need to become the final product, which is glucose, because only the glucose will be absorbed by the intestine villi.
Okay.
Yeah, so that's why the process, which is the maltose become glucose, is being catalyzed by the enzyme called as maltase. So this maltase is happened at where? Okay, it's being secreted out from the ileum. Yeah, ileum. Okay, so ileum is the high part. Okay, it's just like last part on small intestines. We call it ileum. So this ileum, they will have a gland. So this ileum gland will secrete out the digestive juice. Okay, which have the enzyme. Yeah, the enzyme. So the enzyme, they can break down the molecule, become the most simplest form, so they can be absorbed by the intestine villi. Okay, so you clear already. Oh sorry, what is the answer just now? The answer is where the maltose is being digested is at which part? Small intestines, right? So the answer is H.
Yeah.
Okay. Then how about, okay, where trypsin acts? Where is the trypsin? Trypsin X. What I mean by X? X means like they just perform the digestion process. So trypsin will perform their digestion process as which part of organ?
Small intestine.
Yeah, well done. Okay, so H. Yeah, so just like this. Okay, as simple as that. And then for this one, right? This question is a bit tricky lah. Okay, but they ask about what? They ask about investigate the effect of bile on the digestions of fats in the milk. So which is how bile, the bile, okay, the bile able to help in the fat digestions in the milk. Because inside the milk, right, you have the contents such as the fats, okay? Inside the milk, you also have fats. Yeah. So how they able to digest the fats in the milk? So they will have three types of test tube A, B, C. Yeah, A, B, C. So the test tube A will contain the milk and bile, and B will contain milk and the lipase. See, and then C will contain milk, lipase, and the bile. These three substances. And then now they use an indicator that is pink in alkaline solutions and colorless in the acidic solutions. So this is an indicator. Okay, indicator something like it's something like test kit. You heard about test kit before, right?
Yeah.
Yeah. So what this indicator do is they appear pink whenever the solution is alkaline. And then they'll change from pink become colorless whenever a solution becomes acidic. So just pink in alkaline and colors in the acidic solutions. And then they observe the change in test tube for about 40 minutes. And then what will happen? Okay, so in the test tube A, right, initially it's pink color, but at the end, they still remains pink in color. So what this means? This means that the solution still appear in the alkaline, right? So that's why they just still remain as pink in color.
Okay.
Right. Yeah. Okay. But what happened to B? So B, they appear pink for the first 20 minutes, but when they reach about 40 minutes, they become colorless. See, from the pink, right, they change itself, become colors. So what does this mean, Monty? So how's the test tube? I mean, how's the pH of the test tube B now? It become acidic or alkaline already now.
Alkaline.
Okay, see the indicator, right? They just appear colors in the acidic solutions.
Oh, acidic.
Yeah, so now they change become acidic, and then test tube C. Okay, they even change to become colors, which is the solution itself from alkaline become acidic in about 20 minutes. So you can see that this B and C, right? C they have faster rate of reactions compared to B. Because C they change color faster. Okay, because C they appear colors at about 20 minutes. They change the color faster. So that's why you need to expand the result for test tube B and C. Expand the result. And then how you're able to expand it? Okay, maybe Monty, you can think in this way. Okay, so the milk, right? Okay, they ask about what? Inside the milk, they have fats. Okay, so Monty, maybe you can tell me the digestion process for the fats, the equations. Fat plus water, and then break down by the lipase, and then and then they will become what kind of products?
The maltose.
It is a fat. Okay, maltose is the starch, right? It's different. Yes. So for the fat, yeah. Something like acid. Something like acid. This one. It's okay. See. Okay, you read out the answer.
It's fatty acids.
Yeah, fatty acid and glycerol. Yeah. It will change, become the fatty acid glycerol here. Yeah, so become this fatty acid glycerol. So you can see that fatty acid is a kind of acid. Do you agree with me? Because they show fatty acid, right? Fatty acid is kind of acid. So that's why they will change the color. Now the color will become acidic solutions. Because there is presence of fatty acids. Due to the presence of fatty acids, they will cause the indicator change color, become colorless. because showing that it is an acidic solution due to the presence of the fatty acids.
Okay.
And then they ask you to explain the result, okay, and then they give about 4 marks. So how are you able to write these 4 marks question, right? So you can see the B and C. Okay, what's different in the B and C? The B, right, they just given the milk and the lipase, but the C, they are just given with the milk. They are given with the milk, lipase, and bile. So what's the conclusion from here? All right. So now what do you think? Okay, Monty, B and C, right? You think which one have a faster digestion faster rate for the digestion of fat?
C.
C. Okay, why is C? Why?
Because it turned colorless faster.
Yes, it's a color faster. Okay, and then what's the theory behind? Why together with the lipase and bile, right, it will make the reaction appear faster? Why if there's only milk and lipase, right, the reaction becomes slower?
Because bile.
What do the bile do?
It's alkaline, right?
Yeah, bile is an alkaline. Yeah, bile is an alkaline. But what's the function of bile?
It breaks down.
It breaks down. It breaks down what kind of the molecule?
Starch.
Okay, bile is not breaking down the starch, right? Bile, they will help to do a process called as what? Emulsification. Yeah, this one. Which is here, see? So bile, okay, it's being produced by liver and then it's stored in the gallbladder. So whenever the small intestines, they need the bile, right? They will secrete the bile, okay? They just secrete the bile in the duodenum by the bile ducts. So what is function of bile? Yeah, as what you say, bile is an alkaline. Okay, bile is alkaline. So what they do is they will do the emulsifications. This one.
Okay.
Yeah. So Monty, what is meant by emulsification? Maybe you can explain to me. What is meant by emulsifications?
It breaks down big molecules into smaller molecules.
Yeah, okay. If you write breakdown, I just worry that exam will not get the correct answer. So maybe you can write in this way. Okay, bile, okay, they will just perform the emulsifications. So they'll just helping to like convert the large liquid droplets become small droplets. Okay, I should write these emulsifications from large become small droplets. And then second, in order to provide the large surface area for the enzyme digestions. Okay.
Okay.
Those are the keywords. Okay. So this is their first functions. Okay. And then second function, so remember there's another one more functions. The bile, okay, because it's alkaline. So bile able to neutralize the acidic kind. So Monty, where do the acidic kind come from? The acidic kind come from where? Which organ? To the small intestines.
Pancreas.
Acidic kind from the organs, which is acidic. Which is the acidic environment.
Stomach.
Yeah, it's stomach. Okay, it's stomach. And then Monty, one thing just now you talk about the stomach, right? Will have the starch digestions or any kind of something lipid digestions. Okay, the answer is no. Stomach only carry protein digestions.
Okay.
Yeah, okay. There's only protein digestion happen in the stomach. So that's why, and then protein digestion, right? They just prefer in the acidic environment in stomach. Yeah, so that's why whenever the food just come out from the stomach, get into the small intestines, now the pH, right, initially is, because in stomach pH is about 2, pH 2. So whenever the food contains, which is this one, acidic kind, so stomach will produce the acidic kind. Acidic refer to your pH. Kind refer to the semi-solid state of the food.
Okay.
Because the food is mixed with water, mixed with juice in the stomach, right? So that's why when they come out, become semi-solid already, and then they just enter to the small intestines.
Okay.
Yes. Yeah. So the small intestines, they will create we call it alkaline environments. They will have a slightly alkaline environment, Yeah, because due to the bow, so that's why the bow, they will neutralize the acidic kind. They will change the pH, okay? They will just change the pH. From pH 2, right? They just raise the pH, become pH 7.5, 8, like that.
Okay.
Yeah, so that's why whenever your pancreatic juice, which is being secreted out from the pancreas organs, when they come into the small intestines, okay, they just perform, okay, we call it acts, okay, act in the small intestines. So after they act in the small intestine, what will happen to them? They act in the small intestine, right? And then they will become what? Act in the small intestine, and then they will perform the digestion, okay, digestions. So this digestion process, which is digestions, including this starch, protein, and lipid, they are all happen in the alkaline environments. Alkaline environments.
Okay.
Yeah, which is around pH 8 like that, okay? pH 8 around that. Okay, and then we go to the question. So that's why Monty is very important. We should attend more questions. Yeah, very important. Okay, let me show the answer. How is the answer? Answer is at here. Where is it? Chapter 23. This is the actual, just the actual past year exam.
Okay.
Yeah, okay, I just show the answer, so it knows how to write it. Is it? Yeah.
Okay.
Oh, sorry, it's not this question. It's another question. It's okay. I didn't find the answer. Okay, we just write it down. Yeah, so that's why explain the result. So you can say what? You can say about the test tube C, right? They should have they has a higher rate of the fat digestions. Okay, compared to test tube B. Because test tube C, okay, they just change their color, become from okay, you can say that from pink to become colorless at 20 minutes, which is shorter time than test tube B, which require 40 minutes, around 40 minutes. Okay?
Yeah.
So you just explain it, explain the test tube C is faster than test tube B. And then now you need to explain. Okay, Monty, whenever you look at this question, right, explains what? Explains means that something like Monty, how do I say explain the reason behind. Explain the reason behind. Monty, for example, you didn't attend class for today. Will describe, okay, because the question will come in this two way, okay? Sometimes they ask you to describe. And then sometimes they will ask you to explain. When you describe about what? You just describe that, okay, you just didn't attend class today. That's all. Describe the scenario. Understand?
Yeah.
Yeah, but when you explain, you need to explain the reasons. You need to explain the reasons. The reason is why you didn't attend class for today, because you have stomach ache. So that's why now you need to explain the reason. Why test tube C is faster than test tube B. So you can say that because there is the presence of the bowel, okay, in the test tube C. So that's why the bowel, right, what to do? Okay, the bowel, you can say the bowel, the functions, okay, the bowel will do the emulsifications of fats by, as what you say, breaking down, okay, by changing or converts, okay, converting the large lipid droplets, okay, become small lipid droplet.
Okay.
Yeah, so that's why this will able to, yeah, don't forget to write this will increase the total surface area. Yeah, for the lipid digestions. Yeah, by the what enzyme? Lipase. Okay, so test tube B, there's no bowel. Yeah, there's no present bowel. So that's why test tube B, right? Test tube B, due to that has a slower, slower rate of the lipid digestions. Because you can say that due to no presence of bowel. So you can just imagine, right? In the test tube B, because there's no bowel, so that's why the lipid droplet appear very large in their particle. So that's why this would reduce the lipase actions. Okay, so 4 marks. Yeah. So how are you able to get the answer? Yes, anything?
Can I use the toilet?
Oh yeah. Yes, please.
Okay.
And then you can also you can also state about the pH change also. pH will change from alkaline become acidic because due to the presence of fatty acids.
Okay.
Yeah, fatty acid. So that's why the fatty acid will cause the indicator become colorless. Why there's production of fatty acids? Why fatty acid be produced? Because lipase will digest the fats. I mean they will break down the fats, so they will become fatty acids. Yeah. Okay.
Okay.
Yeah, and then explain the purpose for test tube test tube A in the table. What's the function of test tube A? Because you can see it, you can say that in the test tube A, right, there's no lipase, no lipase. Okay, so Monty, you see in the test tube A, because there's no lipase, only milk and bile. So at this case, right, at these conditions, will the lipid digestion take place? What do you think? Will the lipid digestion take place in test tube A? Just the milk and the bile. No lipase, no lipase.
Yeah, no.
It will not take place, yes. Because bile itself, right? Bile is not an enzyme. Bile is not enzyme. Bile will not able to carry out the chemical digestions. So they're able to change the fats become fatty acid glycerol. Yeah. So that's why what's the purpose for test tube A, right? Just acting like control. Yeah. So it's used to compare with the tube B and C to assess the effect of lipase and bile. So it shows that the bile does not chemically digest the fats. So that's why in the test tube A, right, there's no production of fatty acids because there's no fat digestion happen. So that's why the bile will not make the solution become acidic due to no fatty acid being produced.
Okay.
Yeah. And then for this one, right, you want to draw a curve, right? Yeah, this one, the actions of lipase is affected by the temperature. So lipase is a kind of enzyme. So this enzyme is very sensitive towards the change in the pH and also temperature. So what's the effect of the temperature on the activity of lipase? So you need to complete the graph, right, by drawing a line. Okay, drawing a line showing the effects temperature on the activity of lipase. So just around like this, okay. If I draw in this way, right, you can just follow me to draw the graph, okay. just showing that, this is the, let me use, okay, yeah. So you can see that this is the temperature, okay, and then this is the enzyme activity. So initially, the temperature, right, is around like this, okay, around 10, 20, 30, and then 40, okay, 40, and then 50, and then 50. And then initially, right, your enzyme activity will increase whenever the temperature increase around like this. Oh, sorry. My hand is shaking. Okay, just withdraw again. Oh. Yeah, it's around like this, okay. Increase until when they reach the optimal temperature, which is around 37, okay. And then they will become plateau. And then later they will, if they just exceed the optimal temperature, okay, which is around 37 or 40, and then they will just reduce. Like this.
Okay.
Yeah, so this is we call it the optimum temperature, which is around 37. Yeah, 37. So what's mean by optimum? What's mean by optimum temperature? Monty, how you able to define the optimum? Optimum. This one.
If like how like
yeah, which is the yes?
The enzyme activity is the highest, then the temperature
yes,
is
correct. Yeah, correct. You have a highest rate of enzyme activity. It's called optimum. Okay, that's all. And then for this one, right, you need to complete the functions of the digestive enzyme. So you have about pepsin, trypsin, and I don't know what is this. Okay, so pepsin. Okay, Monty, what is the function of pepsins?
It breaks down.
Yes, break down. Yeah. Protein.
Oh, okay.
To become what?
Amino acids.
Amino acids. Okay, it's not too. Amino acid will happen in the small intestines.
Oh.
Okay. Protein will become polypeptide or peptide first.
Okay.
Yeah. So because pepsins, okay, pepsin is happen at where? Oh, stomach. Yeah. So here site of action will be the stomach. Yeah, stomach. So just imagine this way, okay, initially is the proteins, okay, like the proteins, this big structure is the proteins, they are being broken down into the peptide, okay, which is like this, okay, the change, this is a peptide, okay, is being joined by the amino acids. Yeah, so from the proteins, they become the peptide, okay, sorry, this one polypeptide. Yeah, polypeptide. It's being broken down by what kind of enzyme? Is being broken down by the pepsin, yeah, which is this enzyme, okay, pepsin. But later, from the polypeptide, become what? Okay, there will be enzyme, okay, cutting them like this, okay? So from polypeptide, maybe they'll become something like dipeptide. Dipeptide. Do you know what's meant by dipeptide?
Yeah.
Something like two amino acids joined together like this, right?
Yeah.
Yeah. So so from the polypeptide become dipeptide, it will be by the something like the trypsins. Okay. So here is a trypsin. Oh, trypsin. Yeah. So later from the trypsins, yeah, from the trypsin, right? And then from the dipeptide, okay, they will further break down. Now become amino acids. Like this. So like this, just an amino acid. Okay, just free moving amino acid. So for the amino acid, it will be like we call it's absorb. Okay, there will be absorption. Okay, absorbed by the intestine villi. Okay, so it's just like the whole process. And then what's the enzyme break down the dipeptide become amino acid? It will be the erepsins. Erepsins.
Okay.
So when you look at the notes, right, it will show you this. See, so starting from the start march, see, from the proteins, so by the pepsins, they become polypeptide. Okay, which is polypeptide change. So when they enter to the small intestines, for the small intestines, right, the trypsins, the trypsin, they just break down the proteins, okay, become the peptide. Yeah. Like this, okay. When the polypeptide plus the water, right, become the peptide or the dipeptide. So when they enter to the ileum, okay, ileum you have the acids. Yeah. So now from the peptide become amino acids. So this
Okay.
happens in the ileum. Yeah, this happens in the ileum. Oh. Okay, so that's why the function of trypsin is what? Yeah, they will just break down, okay? Break down protein. Sorry, break down the polypeptide, polypeptide to become dipeptide.
Okay.
Or sometimes you can say that they can break down the proteins. Okay, proteins become peptide. Yeah, become peptide. It's not amino acid yet. It's still peptide. Peptide is still need to be further break down again. So this happen in the small intestines. Okay, SI, small intestine. Oh, what happened? Okay, it's happened in the small intestines. SI. Okay, and then Monty, for this one, yeah, now it's your turn to answer. What kind of enzyme break down maltose become glucose? What's the name of it? What's the name of the enzyme?
Lipase.
Okay, this is maltose.
Oh.
Yeah. Yeah, it's okay. You just need to convert. You see, maltose, right? You just convert the words. Yeah, maltase. Yeah, this is the enzyme, okay? You just need to convert the word only. Yeah. So that's why Monty, you realize that the enzyme, the last three words, right, will be this one, ASE. So you just convert the word only. Okay, for example, right, when you look back except the enzyme like the pepsins, okay, like the pepsins. But when you look at this enzyme, right, for example, the starch, okay, you see, salivary amylase, there will be the ASE behind. Yeah. And then when you look at some of the name of enzyme, right, they are very closely related to their process. So for example, lipase, okay, they just break down lipid. So lipase break down lipid. So Monty, lipase only can break down lipid. Lipase unable to break down the proteins, unable to break down the maltose. Okay, because this enzyme, right, their shape is not complementary. Yeah, so only lipase break down the lipid. So only the maltase, yeah, see, only the maltase able to break down the maltose become the glucose. And then only the so Monty, you just need to convert the name. For example, like this lactose. Lactose. Okay, what's the name of the enzyme to break down lactose? OSE, right? Change become ASE. So what's the name of enzyme? Which is the lactase. See? Lactase.
Oh, I didn't turn on my mic on.
Yeah. Okay. I also didn't hear your sound just now. I thought you just remain silent. So your answer is lactase, right?
Yeah.
Yeah. Now see, sucrase is an enzyme. They just break down the sucrose plus the water. Yeah. See, sucrose plus the water, because sucrose and lactose they are belong to the disaccharide. Okay. They are 2 units of the glucose, 2 units of sugar.
Okay.
So the maltase break down maltose to glucose, and this also happen in the small intestine. Okay, in the small intestines. Yeah. And then the stage in the protein synthesis. Okay, that's all for this. And then
Okay.
I show you some of the questions. Okay, So this is just one of the questions. I show you another kind of questions. Okay, and then you can try to do a few questions again. Yeah, see, Monty, how you able to answer? See, explain why lipase. The question asked about this one. Why lipase cannot be used to catalyze the proteins? See, lipase unable to break down protein. Why? Because their shape is not complementary. Yeah, so you can write in this way, the shape of lipase is not complementary to shape of protein. You will get about 1 mark. Yeah, so that's why the protein is unable to bind to the active site of lipase.
Okay.
So that's why you're unable to form the enzyme substrate complex. Cannot form this enzyme substrate complex. So there's no product formations. Yeah, so this is called what? This is we call as the enzyme specificity, okay? Enzyme specificity. And then for this question, right? These questions. Digestive enzymes are being secreted into the alimentary canals. So as well as enzyme, other substances they are important for the digestion are also secreted in the alimentary canals. So what kind of the substance which is very important for digestion, and then they can be secreted out to the alimentary canal, which is your digestive tracts, except the enzyme. So we another kind of substance, including the bile. Okay, bile is just one of it. Bile and this one insulin. Okay, oh sorry, yeah, insulin.
Okay.
Oh sorry, it's not insulin. Mucus. Because insulin is just a hormone. Monty, insulin is just a hormone. Insulin, what they do is they will just reduce the glucose level, right?
Okay.
Insulin cannot help to cannot help in your digestion process. No, so other kind of substance include the mucus, okay, mucus and the hydrochloric acids. So these two kind of substance they will help in the digestion process. And then for this one, you can see this student they get the wrong answer. Why? Because they I think he didn't read the answer correctly. So that's why name the enzyme. Okay, so this enzyme is an amylase. Amylase is being secreted out in the salivary glands, and then I think see X. Enzyme X is referred to the place which they do the digestions. So amylase they are being performed at the mouth. So what's the product? The products is the maltose or glucose, because amylase, right, they will help to break down the starch. So from the starch, right, they become maltose or glucose. And then so second is correct. Okay, the pepsins in the stomach, so they will just acting in the stomach, so they will break down the proteins, become the amino acids. Okay, they become amino acids. Or you can say peptide also can. You can say peptide also can. Polypeptide or peptide. And then the lipase, okay, lipase is being secreted by pancreas, and then they're just acting at the duodenum. So what is the product? The product is the fatty acid glycerol. Okay, and then what is this one? The name of enzyme, okay, which is maltase, acting in the small intestines. So they will break down the maltose, become glucose. So this answer is a glucose. So Monty, you know how to answer this kind of questions?
Yeah.
Yeah.
But
so
like,
yes.
I think it's still kind of hard to like match each enzyme with each substance.
So that's why you need to memorize the enzyme very well. You need to memorize it. Okay, it's okay. Because I understand now. I think when I'm in your age, right, I also tend to forget. So how I'm able to remember back, especially during exam. So I will just recall by using this kind of notes that I show you. I think I sent to you before. I think I sent to you also. Where is it? I want to share the notes. This one. Okay, chapter 7. Because you are going to taking the exam in another 2 years, maybe.
No, it's next year.
Oh, next year. Okay, next year. Next year means is next year. Which one?
What do you mean? Which one?
Oh, I mean your IGCSE exam.
Yeah.
You're taking next year. Which one?
Yeah.
Do you know?
I think about that time.
Oh, next year. Oh, next year June. Okay. Yeah. Next year is 2027, right?
Yeah.
Okay, okay. I get you. Okay, because Monty, now my mind is still in 2025.
Oh,
So
okay.
when talk about next year, I'm thinking, wow, you're taking exam in this year. I'm shocked. I'm shocked.
Oh,
Okay, I forget it's 2026 already. So it's like time fly very fast. So you'll be taking exam in next year, 2027, in the June,
Yeah.
right? June or May, around that.
yeah, around that time, I think.
Okay, okay, it's okay. So that's one thing we need to pick it up already. Yeah. So you just can read this note, read this note, and then see the digestion enzyme. And then you need to know about the definitions. Okay, the definitions. Yeah, for example, like this, right? What is meant by ingestions? Yeah, and then digestion. Okay. Sometimes I'll just put the star at here. Okay, I put the star because this is very very common questions in the exam. So that's why I just put star here. At least you need to know. Okay.
Okay.
Yeah. So for example, what is digestions? Digestion is referred to breakdown of the food molecule. Includes the physical digestions and the chemical digestions. Yeah. See, when we talk about digestion, right? It includes the chemical digestions and the physical digestions. Okay, and then the physical digestion, right? Physical, you just like making the piece of paper, right, into a smaller piece physically, yeah, because you just change your physical form. Understand?
Yeah.
Yeah, but the chemical digestion, right? You are not changing the physical form. You also change their chemical structures. So that's why from the large insoluble molecule, they become small and soluble. Yeah, see, from insoluble become soluble means that chemical structure is being changed already. Yeah, so that's why this is different in the definition. So only the enzyme, Monty, only the enzyme able to perform the chemical digestions. So you can see, for example, this is a physical digestion, okay. Okay, how you would describe it? So physical digestion is breakdown of the foods into the smaller piece. Breakdown of food into the smaller piece, okay, without, see, the keyword, without chemical change to the food molecule. Okay, because you just change your physical structure only. You didn't change your chemical structures. So that's why you need to do the physical digestion, because you want to increase. So this one, just like what you answer in the question. You need to increase the surface area of food for the actions of the enzyme in the chemical digestion later. So this is the keyword. Increase the surface area.
Okay.
Yeah, so example of physical digestion would be what? Would belong to the, for example, like the chewing action in the teeth, chewing, and then the churning action of stomach. Okay, you know your stomach, right? They can do the churning. Yeah. Something like, so Monty, if you didn't eat the food, right, you feel that stomach is like churning. Can you feel? And then you feel very, very uncomfortable.
Yeah.
Yeah, and also emulsification. Just like to talk about emulsifications, also is a kind of the physical digestions. Because they just change their physical form only. From large becomes small particle. Okay, and then what is a chemical digestion? See, this is chemical digestion, so it's break down the large insoluble becomes small and soluble molecule. And then okay, the role, okay, why you need chemical digestion is because that the large insoluble molecule, they are unable to absorb. Yeah, because you are unable to absorb this kind of large insoluble molecule throughout the intestine villi. So that's why you need to convert it become small and soluble molecule. Only that you can absorb into the intestine villi. So that's why you require enzyme, a lot of enzyme. Okay, and then here's the name of enzyme. Yeah, so later we'll do revision, right? Just need to revise based on this template. Okay. Yeah,
Okay.
I hope it will make easier for you to revise. Because you just need to read through the question and the answer. So this is so you just need to know about just few enzymes. You need to know about amylase, okay? Amylase. So amylase, okay, they break down the starch, become maltose. And then amylase is being produced by the salivary glands and also pancreas. So there will be two places throughout the amylase. And then the proteins, okay, protein is happen in the stomach only, okay, I just write here, okay, stomach only, remember, there's no other kind of organs, okay, proteins, stomach, okay, and also the small intestine, sorry, there's one small intestine also. Small intestine, they have an enzyme called as trypsin, so the pepsins, okay, they are being produced in the stomach, and then they just work in the stomach. And then tryptophan also, they produce a pancreas, so they'll be work in the small intestines.
Okay.
And then the bit.
This document, can you send it to us?
Okay. I think I sent to you before. It's okay. I resend again. Yeah, no problem. I
Okay.
resend again. Yeah.
Yeah.
Okay. Here. Okay, here, hold on. Chapter 7.
Thank you.
Okay, chapter 7.
Yeah.
Oh, we did
Okay.
in the WhatsApp group. Yeah. Okay. So I will continue. So see the chyme. Okay, chyme is being produced in stomach. Yeah. So and then the functions. Okay, sometimes they will ask you this one. Yeah. What's the function of the hydrochloric acid in the stomach? So hydrochloric acids, after they've been produced in the stomach, right, they will have two functions. So Monty, you need to remember about two functions. First is hydrochloric acid, right? They just kill the bacteria. Because the bacteria, they cannot tolerate such as highly acidic environment. So that's why the pH, the hydrochloric acid will give the stomach about pH 2. pH 2 is very, very acidic. pH 2 is super acidic.
Okay.
So that's why your stomach lining, right, they will have the mucus. You know, there's a mucus. Maybe I can write here now. Sorry. Mucus. Because the stomach is too acidic. So the mucus, they'll just line up, okay, line up the lining, stomach lining, okay, to protect from being corroded by the acid. Yeah. So it just a mucus. Okay, mucus found on the stomach lining. Yeah. So that's why the hydrochloric acid, they can kill bacteria. They also can provide. They can provide the acidic pH. This acidic pH. So they can create the acidic pH, right, for the enzyme pepsin to work. Because Monty, you know the enzyme pepsins. Okay, what is the optimum pH for the enzyme pepsins? Optimum pH.
It's
2.
1 2.
Yeah, it's 2. So that's why they just prefer to work in this kind of pH 2 environment. So if you raise the pH become pH 3 and 4, right, it will affect their functions. Means the enzyme pepsin, right, they're unable to do their work because the pH is being changed, right? And then, okay, why bile is alkaline? It's because first, they want to neutralize the acidic mixture of the food. Yeah. And then they will provide the sugar pH for the enzyme actions in the small intestines. Okay. So this is a bile.
Okay.
Okay. So I'll show you another kind of question. So you just have a look. Yeah. Okay. So this is because Monty, in the actual IGCSE exam, they will just not come out only one topic for one questions. They will just mix about 2-3 topic in one questions. So that's why they like to ask the chapter 4, which is the biological molecule, and chapter 5, enzyme, and also this chapter, human nutrition. They like to combine these 3 topics together, become one questions.
Oh, okay.
So that's why you see this one question, right? They ask about what? Human nutrition. They ask about enzyme. They just mix them together. Okay, so for example, this show about the pepsins. Okay, pepsins are being measured at a different temperature. So you can see, right, they are just increasing and then they're decreasing. Yeah, so this is the curve. Okay, the curve increase and decrease. Monty,
can you send it to me also?
Oh yeah, this one I will send to you, and then you can read the answer, right?
Yeah.
Okay, I think I sent to you before. It's okay. I will send again. This one. So Monty, okay, for today's class, you can continue to do the homework for the paper 4. Okay, I think you need more practice.
Okay.
Yeah. This is chapter 7, human nutrition, paper 4.
Okay, thank you.
Yes. I think let me finish about this question, and then you can go for dinner. Okay. Yeah. So see, the question asks about what? See, describe and explain the effect of temperature on the activity of pepsins. They also describe and explain. How many marks? 6 marks. Okay, Monty, in the IGC exam, right, they only give you maximum 6 marks only. Do not have about 6, 7, or 8. No, maximum is only 6 marks. And then this 6 mark question, right, they will come out in the describe and explain. Which is you need to give 3 marks for descriptions and 3 marks for the explanations. You know what I mean?
Yeah.
Yeah, so that's why how you're able to describe and explain. Okay. See, yeah, whenever you look at this curve, right, you should know that what's the optimum pH. So you can say that 39 to 40 degrees Celsius is the optimum temperature with the highest enzyme activity of the this one 2,500 U per mg proteins. So Monty, whenever you describe I mean this graph, right, you can describe in this way. Okay, which spot will be the optimum? You need to identify. Okay, this is the optimum, and then this is showing the increasing trend, and then this showing the decreasing trend. And then don't forget, whenever here also showing that there's no enzyme activity, because when the enzyme activity shows zero means that there's no enzyme actions happen. It's also one of the point. Okay, so there'll be 4 points. Increase, optimum, decrease, no activity. Remember this 4 point. If you want to describe the enzyme curve or even the pH curve also.
Okay.
Okay, so you can see how they describe it. Describe. Okay, now I'm still describe. I haven't explained the I haven't explained the reason. I just describe why it increase. I just describe increase, decrease like this. So second step is there is a steeper decrease. Okay, which is you can see from this graph, right? The decrease starting from from 40 degrees Celsius. From 40 they decrease to 60 degrees Celsius. So a steep decrease. This one steep decrease. Okay, Monty, what's mean by steep decrease? Refer to it decrease very fast.
Yeah. Okay.
Just like skyrocket, very fast. Okay. Yeah. So that's why there is a steeper decrease in activity in the enzyme activity after optimal temperature, and then there's no enzymatic activity after 62 degrees Celsius. So they become zero at all. Okay, no. So this is descriptions. Okay, and then now you need to explain it. Okay, there is an increase in temperature. Increased temperature, it will cause increase in the enzymatic activity. Because why? Because that you are actually increasing the kinetic energy. Okay, of the substrate and the enzyme molecule. Yeah. Okay. Increase temperature, increase kinetic energy for the substrate enzyme molecule. Yeah. So this will increase the frequency of the effective collisions. And then it will increase the formation of the enzyme substrate complex. Because you are increasing the kinetic energy, right? So that's why they can collide more frequently like this. So that's why the enzyme substrate, right, they can increase their formation because they can collide more frequently. So it will increase formation of enzyme substrate complex. So later the protein denaturations occur at above optimal temperature. Okay, because you increase the temperature, exceed the optimal temperature already. Okay, which is more than 40 degrees Celsius. So you will denature the proteins. So when you denature the proteins, it will cause a change in the enzyme at this site. So they'll be no longer fixed into substrate.
Okay.
And then for this one, okay, explains why lactase is important for the nutrition of the young baby. Okay, lactase is called enzyme. This enzyme will break down the lactose. Okay, lactase break down lactose. Yeah, so that's why it's very important for young baby, because young baby they drink a lot of milk, and inside the milk they have a lot of lactose. Okay, so that's why lactose is the main nutrients they are found in the milks for baby. So that's why lactase. Okay, lactase will digest the lactose. Like this.
Okay.
And then symptom of diarrhea, okay, is watery feces. Diarrhea means watery feces. So whenever Monty, you are able to digest the food that you eat, right? You will have diarrhea. If you
Okay.
I mean, if you're unable to digest the food that you eat. Okay, so we finish about these questions, and then I give you some homework. Okay, we'll try some questions for this paper.
Oh, okay.
Okay. So that's all for today. Okay, bye.
Okay, bye.
Bye.